We're talking about section 11.1, page 744, and I'll just call this statistics. And so what we're going to start by talking about is we're going to start by talking about measures of central tendency. And there are three different measures of central tendency, and those are mean, median, and mode. The mean is really just another name for what? Average. This is your average. The median is the middle value. When arranged in order from least to greatest. I guess technically it could be greatest to least, but we only arrange these least to greatest. Mode is the one that a lot of times people are a little bit confused on. What is the mode? What do you mean by the most? Yeah. This is the value or values that occur more than the others. And you can have more than one mode. If there's more numbers that occur more times than the others, then there's more than one mode. So we're going to start by taking a look at the mean, then we'll take a look at the median, and then we'll take a look at the mode. So let's start by taking a look at the mean. So the mean is the average, and the way you take the average is you add them up and divide by how many you added. Okay, so let's take a set of numbers. Let's take 13, 7, 24, 11, 7, 9, 7, 13, 11, 12. So if we want to find the mean, and the way that we symbolize the mean is x with this little line above it. We read that thing as x bar. Stands for the mean. That's the official name of that symbol, x bar. It's the symbol for the mean, the average. So what we do is we add these all up. So I'm going to take my calculator out. And so let's clear that. We have 13 plus 7 plus 24 plus 11 plus 7 plus 9 plus 7 plus 13 plus 11 plus 12 is going to be equal to 114 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers gives us 11.4. That is our average, our mean. Okay, that's x bar. Questions about that? We don't have to put anything in order for this. We just add them up and divide by how many you added. Now, the median requires that we put these in order. Otherwise, the middle value would have absolutely no meaning. So, the smallest number here is 7, and we have 3 of them. Notice I crossed them off. I highly recommend that when you guys write down a number, you cross it off of your list so that you know if you used them all or if you left something out. So then we have 2 11s. We have a 12. We have 2 13s. And we have a 24. Notice I've crossed them all off, and notice I have 10 numbers up here, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers there, so something's missing. Right, so there were 2 13s, right? So always do that double check to make sure that you have the same number of entries that you had to begin with. Now we have 10 again. Now what we do is we start crossing them off from both ends. So we cross off 1 there and 1 there. And we cross off 1 there and 1 there. And we cross off 1 there and 1 there. We cross off 1 there and 1 there. We cross off 1 there and 1 there. And you keep doing that until you arrive at a central number. If you arrive at a central number, then that means that that number is your median. If you don't arrive at a central number, and you have really 2 central numbers, what you do is you average them. So you add them up and divide by how many you added up. So that's 22 divided by 2, which is 11. Those both happen to match, so our average ends up being the same. So there is our median. Questions about that? Notice, was the median the same as the mean? No. Typically, is the median higher than the mean or lower than the mean? It just depends on the data, actually. It just depends on the data. Okay? All right. So make sure you put them in order. Start crossing off from both ends. If you arrive at 2 center numbers because you had an even number of values, then you just add them up and divide by 2. Any questions about that? Okay, the next thing we need to talk about is the mode. And for the mode, you need to look at how many times everything occurs. So we have a 7, and there were 3 of those. Right? We had 1 9, we had 2 11s, we had a 12, we had 2 13s, and we had a 24. Is there a particular value that occurs more times than the others? So that means that our mode is 7. Okay? It's the most commonly occurring value or values. What would happen if I threw another 11 out here? Then what would my mode be? 7 and 11. You could have 2 modes, right? What happens if I threw another 13 on here? Now what? What happens if I threw some more 9s in here? What if I threw some more 12s in here? And finally, what happens if I throw some more 24s on here? If all of them occur the same number of times, guys, then none of them occur more times than the others, and therefore there is no mode. So you can have as many modes as there are numbers minus 1. You have to have 1 less. Because if they all occur the same number of times, then none of them occur more times than the others, and therefore there is no mode. So if they all occur once, there's no mode. If they all occur 20 times, there's no mode. If all of them except 1 occur 20 times, and that other one occurs less times, then all those others are modes. But you cannot have all of them be the mode, because if all of them are the mode, then there is no mode. Yes, ma'am. I'm trying to think. Our book doesn't use any of them. Our book only uses the X bar. Sometimes, I believe, for median, occasionally some books may use the X with a hat on top of it, I believe. That's called X hat. And I believe that gets used for median, but that's something that we're not going to see in our book. The only one in our book is X bar. Okay? And I've never seen anything for mode. Okay, questions about mean, median, or mode? Okay, the next thing that we need to talk about is I want to talk about the spread of data. So you may be looking at numbers, and maybe you have, 0 and 1 and 2, and you have, 12 and 13 and 14 up to here, and you have everything in between. And you have one of those, and you have a couple of those, and you have a couple of those, and you have, one of those, and then you have a whole bunch in here. And so maybe your median ends up right in between these, and your mean ends up right in between these. Okay, so let's say x bar would be right in between there. But you could also have one that looks like this. Do you guys see that the mean would still be in the same place? And if I average these all out, it's going to average right in the middle there because we're balanced on both sides. Everybody see that? Do those two data sets look the same to you, though? No, one of them is considerably more spread out away from the mean than the other one. So that's what we mean by data spread. Okay, everybody clear on what we're talking about there? So how spread out is your data? The median and the average don't tell us how spread out the data is. They only tell us about where the middle is in two different ways. We don't know about the spread. So the first way to talk about the spread is what is called range. I don't know if they actually give you any of these problems, but I want to talk about it because mean, median, mode, and range are typically taught together. Range is just the largest value minus the smallest value. So in our example, we had, what, 777. And then we had a 9, 2 11s, a 12, 2 13s, and a 24. So we had a 9, 2 11s, a 12, 2 13s, and a 24, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So what would our range be here? Our range here is equal to the largest value minus the smallest value, which is 17. So we would say that we have a range of 17. That tells us that the difference between our biggest and our smallest values is 17 units. If I go back and look at this, do you guys see, let's say this was 9, 10, 11, 12, 13, 14. The range here would be 14 minus 9, which is 5. That's pretty close together, whereas the range here would be 14 minus 0, which would be 14. So you can see that the more spread out one will have a much greater range. Everybody get that idea? Okay, so that's the idea of range. Bigger the range, the more spread out the data is. The next one I want to talk about is I want to talk about standard deviation. This is an important one. And while we don't really use standard deviation, I need to show you how it's computed because they could ask you that on the CSTs next week that we're going to start reviewing for this week. Standard deviation uses the symbol sigma. Okay, this is the lowercase Greek letter s. That's sigma. The capital S, sigma, is this one. Looks kind of like the E. We use this for summations. Okay? So sigma starts with S. It really means summation, meaning we add things together. The way that you find the standard deviation is the standard deviation is equal to the square root of x1 minus x bar squared plus x2 minus x bar squared plus x3 minus x bar squared plus dot 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 divided by, sorry, this goes all the way up to xn minus x bar squared divided by n. So n is the number of pieces of data that we have. And each one of those x's with a little number after it, the x1, x2, x3, represents one of our pieces of data. So for example, let's do a simple example. Let's say we have 3, and then we have 7, and then we have 8, and then we have 11. And let's see, that's 15, 26, 29. 29, and let's say we have a 6 in there. That'll work. So 14, 25, 35. Okay. So if you add these all together, x bar is equal to 3 plus 6 plus 7 plus 8 plus 11 divided by 5. So that's 35 divided by 5, which is equal to 7. So that's our x bar, our average, our mean. Everybody with me? To find our standard deviation, what we do is we take the square root of, what was our first piece of data? 3, and we subtract the average from it, which was 7 squared. Plus, what was our next piece of data? 6 minus 7 squared, plus our next piece of data. What is it? So 7 minus 7 squared, plus 8 minus 7 squared, plus 11 minus 7 squared. The whole thing is divided by the number of terms, number of pieces of data, which is 5. This will give us our standard deviation. Notice this gives us the square root. 3 minus 7 is negative 4, squared is 16. The reason we square it, guys, is so that negatives and positives don't end up killing themselves off. We're trying to find a distance. So we square it to get rid of negatives, and that's why we take the square root at the end. Because if we don't take the square root at the end, we've squared all of our values. We've squared how far away they are from the mean. What each of these little parentheses is doing is finding out how far away it is from the mean, and then squaring that number to get rid of the negative. And that's where the square root comes from, to kind of undo the squares. 6 minus 7 is negative 1, squared is 1. 7 minus 7 is 0. 8 minus 7 is 1, squared is 1. 11 minus 7 is 4, squared is 16, divided by 5. These won't all be mirror images of each other. It's just the way I happen to choose the numbers accidentally on this one. That's 32, 33, 34 divided by 5. And the square root of 34 fifths, I'll go to my calculator. The square root of parentheses, 34 divided by 5, gives us about 2.6. So the standard deviation is about 2.6. Now again, we're not really going to use standard deviation for anything, but what it's used for when you take statistics, those of you that go on to stats next year, you do things like work with standard distributions. A standard distribution is a bell curve. And right in the middle of this bell curve is x bar, your mean. And if you go one standard deviation, in other words, 2.6 in this case, this way, so our mean was, what was our mean, 11.4? No, I'm sorry, our mean was 7, right, on this one? So if we go one standard deviation, which would take us to 9.6, between 7 and 9.6 is 34% of our data in a standard distribution. So if we were looking at grades in a class, and let's say it was a normal distribution, we would expect that between 7 and 9.6 out of whatever it was out of on our test, we would find 34% of the students scored in that distance, or in those scores, in this range. Likewise, if I go one standard deviation this way, So if I subtract 2.6, that would leave me, what, 4.4? Between 4.4 and 7 is another 34%. So altogether, within one standard deviation above or below, we would get 68% of our data if the data is normally distributed, if it's not skewed at all. Okay? And then if you go another standard deviation, you get more of your data. And then you go another standard deviation, you get more of your data, etc. So every time you go another standard deviation, there's a predictable amount of data that you pick up. That's the idea behind normal distributions and standard deviation. That's what it's used for. Again, it's a measure of how spread out our data is. Questions about that? Okay. Now, I think that's all we need to talk about today. The only other thing I want to talk about is a concept of, thank you, an outlier. An outlier is an important concept in statistics, and that is that if you have statistics that are kind of, meandering around and they're kind of looking like this, if you were to plot them on a scatter plot, and you got some stuff in there, and then you got a guy way out there. Any data that totally stands out from the rest of the data set, either on the high side or the low side, is called an outlier. The problem with outliers is they have a tremendous effect potentially on the average, on the mean. So for example, if I have a $100,000 house and a $100,000 house and a $100,000 house, yeah, in Orange County, that's a box under the freeway overpass, right? Okay, and then let's say we have a $200,000 house. Sorry, too many zeros. That's a box under a slightly nicer overpass. Maybe it has a window cut in the side. And then you have a $1 million house. Yeah, $1 million in Newport? I don't think so. All right, it's two boxes under a really nice overpass with lots of windows. All right, maybe even a driveway. All right. So, 100,000, 100,000, 100,000, 200,000. If you look at the overall neighborhood, this is a pretty bad neighborhood, isn't it? But look at the average, guys. If we take the average, 100, 100, 100, 200, and a million is 1,500,000. If we divide that by 5, that gives us an average of 300,000. Do you think 300,000 really represents this neighborhood? No, that's more than almost every house in the neighborhood. Except for the one guy that bought 10 houses, tore them down, right, and made one big house on the plot. That's the idea. But what happens if we look at the median? What would the median be? The median is 100,000. Which one gives us more accurate information at a glance about this neighborhood? The median. And that's why when you guys hear on the news or you guys hear in the newspaper or you hear your parents talk about median house prices in Orange County, that's why we don't talk about average housing prices in Orange County, because that one outlier has a huge impact on the average. But it doesn't necessarily have much impact at all on the median, the middle value, right? I could have made this 200,000 and my median still would have been the same 100,000. Does that make sense? All I needed was one more at or above that highest number and it would have given me the same answer. Actually, all I needed was something anywhere between from here on up and I would have gotten the same median. So that's why different measures of central tendency are used for different situations. Okay, does that make sense? So that's why we talk about different measures of central tendency. They have different applications. Sometimes the average is really what you want to know, right? If you want your grade point average, okay, if you fail all your classes and then you get an A in PE, and that brings your average up to, you know, whatever, you get D's and F's and you get A in PE every year, okay, and that brings your average up to, you know, almost a C. Does that mean you're almost a C student? No, certainly not. Okay? But when we're talking about things, like, you know, hitting averages and things like that, those outliers don't have as huge an impact because you have so many more data values. Where outliers have a tremendous amount of impact is when there's not a lot of data. Okay? I put that $1 million house in a group of 5 housing prices, it has a huge impact. But what if I had 300 homes at $100,000 each? And I had 280 homes at $200,000 each. And I had 1 home at $1 million. Is that million, that outlier, going to have as big an effect as it did here? No. So averages tend to be much more accurate for us when we have a lot of data. If we don't have a lot of data, then we're very sensitive to one outlier, and therefore the median tends to be a better measure. Does that make sense, everybody? So it all depends on the context as to which measure of central tendency you really want to look at. Okay. Any questions about any of that? That's all there is to section 11.1, guys. Mean, median, mode. I taught you range, although I don't know that they're going to ask any questions about it because I don't think it's in the section, but standard deviation. Feel free to use your calculator to do standard deviation. Write down all the numbers like I did here. Okay, and you're going to have decimals involved. Add them up on your calculator, divide by whatever your n is, and then take the square root of the whole thing. Okay, that's it.